Good evening, everyone. So let us begin today's video, which will once again be on rotation. Oh, I have not shared my screen, I think. Just give me a moment. Okay, fine. Right. Right. So the question once again is about moment of inertia. So to find out the moment of inertia of an L joint. So you see this is an L joint. This was a previous JEE mains question. A L-shaped conductor is placed along an XY plane. Okay. And the origin is fixed at O. So at this point, it's been hinged. It's been hinged over here. The rod is free to rotate. Okay, either I can rotate it like this. I can rotate it like this, or maybe I'll be able to rotate in upward direction. The mass and length of both the rods are M and L. ML, ML. Find the moment of inertia of the system passing through an axis, passing through O perpendicular to the plane. Okay, about an axis. So this is the axis. I will write this as a cross with a circle. What do you mean by that? Which means that the axis is perpendicular to the plane. Okay. Now let us begin. So when we have a question like this, the student, what did he do? He started something like this. He found out what is the moment of inertia of this rod about this point. Okay, about this axis. This is nothing but ml square by 3. Okay, he has used parallel axis theorem. He took one axis here. Moment of inertia about the rod about this axis is ml square divided by 12. And here, this distance is L by 4. Yeah, sorry, L by 2, L by 2. This is L by 2, this is L by 2. So the total moment of inertia about O due to this rod alone is nothing but ml square by 4 plus ml square by 12, which should now be equal to ml square by 3. Taking the LCM, I equal to I0 plus mh square. Okay, simple parallel axis theorem. Now what we have is, okay, let us have this one here. Now for this rod we have already done. He found out what is the moment of inertia of this rod also. So with respect to this, so what happens is he assumes that this is moving like this. So as a result of it, it's once again ml square by 3 once again, ml square by 3. And he adds up these two and finally gets the answer as 2 ml square divided by 3. Okay. Now the question is this correct or wrong? Okay. So this is completely incorrect. You cannot add just moment of inertia like this. Now, how do we solve it? Okay, what is the correct solution? Now, let us look at that. Towards it. Now, what do we have here? So, we have one rod here. So, with respect to this part is correct. What he had done is correct here, which should be ml square divided by 3. Now, the center of mass of this rod lies at this point. Okay. So, if you find out what is the moment of inertia of the body at this point, this should now be equal to ml square divided by 12. What is the axis? Axis once again is like this. Okay. So here in the earlier case, he assumed that there is an axis here. We did not have anything like this. So because with respect to this axis, this also moves in a circular path. This also moves in a circular path. You cannot assume something like that. Okay. Now ml square by 12. Now what we'll do is we will draw a line here connecting these two. Okay. Now this truncates to a problem something like you have an object whose moment of inertia is here, axis, and then you have one more mass, which is of mass m. Okay, and this moment of inertia about this point is ml square divided by 12. And this distance we need to know. What is this distance? This is L, this is L by 2. So therefore, this distance should now be equal to, use Pythagoras theorem. So this should now be equal to L square plus L square divided by 4, which should now be equal to square root of 5L square by 4. Okay, so this should be 5L square divided by 4. Now let me say, what is the moment of inertia of this object here? Due to this object alone, this is moment of inertia should be ml square divided by 3. Plus, what is the moment of inertia of this object at this point? Due to this point, due to this axis. Okay, this should now be equal to ml square divided by 12 plus m into parallel axis theorem, mh square, right? M into 5L square divided by 4. When I do this, what do I get here? I get this as ml square by 3 plus ml square by 12 would be, take 12 common over here. And we get this as ml square, 4 ml square, 4 ml square plus ml square plus 5 ml square divided by 4, which should now be 5 ml square divided by 4 plus, sorry, 12, correct? Am I doing right? The 4s are 4 ones are, yeah, 4 by 12 plus 5 ml square divided by 4. Now I want to take the LCM here also. So which should be 5 ml square divided by 12. Let me multiply by this by 3. So I will get this as 15 ml square by 12 also. The 15 plus 5 will become 20 ml square divided by 12, which should now be equal to 5 ml square divided by 3. Right? So this is the correct answer. So therefore, now we have arrived at the final solution. So how easy it is? So the misconception here is that understanding the moment of inertia appropriately and applying the parallel axis theorem. The moment I say about a parallel axis theorem, remember, parallel axis theorem should always be applied when you have one moment of inertia of a rod about the center of mass, and the other one, okay, you can determine it with respect to different axes. If, like the student, what he had applied, if I had applied here, okay, this was not the center of mass of this object. So therefore, you should not apply over here. Okay, is this clear? So how to apply parallel axis theorem? Thank you, friends. Thank you for watching the video. And if you really like this video, do share, comment, and subscribe to my channel for more updates of this kind, so that it will also be helpful for me, appreciate me towards making more new videos. You can also send in across some new topics, as what topics would you like to work on. Thank you.